For countless ages human beings have gazed into the endless darkness of the night sky filled with awe and wonder about the many unexplained secrets that lie beyond our world. In the 1900s, scientists introduced a theory known as the Big Bang to describe how the universe came into being, how it developed, and why it continues to grow. Although this theory gained widespread support, it still fails to provide answers to some of the most basic questions about the cosmos. In recent times, groundbreaking discoveries have made these mysteries even harder to unravel. One such moment came in 2023 when NASA's James Webb Space Telescope detected astronomical objects that appear to be older than the universe itself. This revelation stunned scientists and ignited a heated debate. Could it really be possible for stars to exist longer than the very universe they reside in? Webb's discovery has challenged the current understanding of space and time, raising the possibility that our entire model of the cosmos may need a fundamental overhaul. These types of perplexing questions are exactly what we'll be digging into. If you're fascinated by the cosmos and want to stay in the loop with new discoveries, be sure to subscribe, hit the like button, and turn on the notification bell so you never miss a moment. Roughly 200 light-years away from Earth, in a constellation known as Apis, lies a particularly intriguing star called HD 14283. What makes this star so captivating isn't just its speed, traveling at a blistering 4,483 kilometers per second, but the story hidden in its past. Around 1 billion years ago, during the early formation of the Milky Way, our galaxy collided with a much smaller one, and this star was among the survivors of that cosmic crash. Yet what truly sets HD 14283 apart isn't its journey or speed, it's its age. Nicknamed Methuselah after the legendary biblical figure said to have lived nearly 1,000 years, this star is considered one of the oldest ever observed. Initial calculations put its age at an astonishing 16 billion years. More recent estimates have refined this to about 14.46 billion years with an uncertainty of 800 million years. This still places it older than the estimated 13.8 billion-year age of the universe as calculated using data from the cosmic microwave background radiation. This leads to a puzzling contradiction. How can a star be older than the universe that contains it? This apparent inconsistency has forced scientists to re-evaluate how we measure the ages of stars in the cosmos, driving deeper inquiry into these confounding astronomical riddles. To fully grasp this paradox, we must appreciate the difficulties in estimating the age of stars. Stars like our Sun remain fairly consistent in size and temperature over extremely long periods, making it incredibly challenging to determine their age with precision. Astronomers must monitor tiny changes in a star's light and color and compare them to complex models of stellar evolution. One of the key techniques used is gyrochronology, which involves analyzing how fast a star spins. Just like a spinning top that slows down over time, stars gradually lose their rotation speed. By measuring the slowdown and comparing it to stars of known ages, scientists can use mathematical models to estimate a star's age. Methuselah is unquestionably ancient and by current measures stands as the oldest star we know. But instead of fixating on whether it could be more than 2 billion years older than the universe, perhaps we should flip the question. Could our universe actually be older than previously calculated? Trying to conceptualize 13.8 billion years is no small feat. Imagine compressing all of cosmic history into a single year where the Big Bang happens at midnight on January 1st. Earth wouldn't appear until the last hours of December 31st, and the entire span of human civilization would fill only the final few seconds of that imaginary year. Astronomers have determined the age of the universe by studying light from incredibly distant stars formed shortly after the Big Bang and factoring in redshift, an effect caused by the stretching of light as the universe expands. This data leads to the current estimate of 13.8 billion years, but a recent proposal from the University of Ottawa suggests this might be an underestimate. The theory claims the universe could actually be around 26.7 billion years old. This bold idea was introduced by physicist Rajendra Gupta, who revisited a 1929 theory by Swiss astronomer Fritz Zwicky and paired it with more recent insights. Gupta suggests that over enormous spans of time and distance, protons lose energy, a notion that runs counter to how we currently interpret redshift. Instead of attributing redshift solely to cosmic expansion, Gupta believes it might be a combination of factors. If true, this hybrid explanation could completely alter our understanding of how old a universe really is, potentially resolving several long-standing debates. many of which have come to light thanks to recent findings from NASA space telescopes. Gupta's theory builds upon the tired light concept and introduces something called evolutionary interaction constants, originally suggested by theoretical physicist Paul Dirac, which proposed that the nature of cosmic forces may have changed over time. It's worth remembering that our ideas about the age of the universe have evolved significantly. Back in the 1920s, Edwin Hubble estimated the universe's age to be around 2 billion years. Over the decades, more accurate observations have adjusted that number upward to the current consensus of 13.8 billion. Whether we think of human history as a few seconds or milliseconds on a vast cosmic clock, there's no denying that the universe is incomprehensibly ancient, and its ongoing expansion constantly challenges our previous assumptions. Meanwhile, scientists are making fascinating observations about our own Milky Way. For example, recent data has shown that stars on the outer edges of our galaxy move much more slowly than stars in other galaxies. One theory is that the Milky Way contains less dark matter than we thought. Dark matter, though invisible, plays a major role in how gravity behaves on a cosmic scale. Another possibility is that our understanding of how dark matter is distributed across the universe is flawed. This mystery arises from information gathered by the European Space Agency's Gaia mission, which has charted nearly 2 billion stars in our galaxy. These findings have made astronomers rethink how stars behave, especially at the fringes of the Milky Way. The speed at which stars orbit is directly tied to the galaxy's total mass. Gravity's grip depends on how much matter, both visible and invisible, is present. A recent analysis using Gaia's data suggests that the Milky Way's mass, including stars, gas, dust, and dark matter, might be about 200 billion times the mass of our Sun, which is 5 times lower than earlier projections. This drastic reduction could imply a surprising lack of dark matter. Still, calculating a galaxy's mass is extremely complicated, and uncertainties in satellite data or in the analytical models used could skew the results. As we gather more refined data and develop better instruments, we'll continue to track these developments. Looking ahead, future technological advances in space missions will likely illuminate many of these unresolved cosmic puzzles. The James Webb Space Telescope, with its unmatched power, is pushing scientific boundaries in ways never seen before. Its mission goes far beyond estimating the ages of stars or the universe itself. It's also revealing the inner workings of galaxies, the strange properties of dark matter, and the unseen forces shaping cosmic evolution. The expansion of the universe is still a central mystery, but as new information comes in, we might learn that our long-held assumptions were incomplete or even incorrect. A critical question remains: do the laws of physics we rely on work the same way everywhere across every scale and age of the universe? Could there be hidden forces or unknown phenomena that affect how galaxies behave and how stars age? As our instruments become sharper and more capable, we may stumble upon discoveries that shape the foundations of modern science. Experts are beginning to realize that we're only scratching the surface when it comes to understanding dark matter, dark energy, and the fundamental interactions that govern the cosmos. Every new observation, from distant galaxies to ancient star remnants, offers clues about how the universe functions. But these clues often generate more questions than answers, pushing the edges of human knowledge ever outward. The possibility that stars might predate the universe or that the cosmos itself is much older than we thought forces a total rethinking of modern cosmology. It suggests we may need brand new physics, innovative theories, and perhaps a completely different way of viewing the fabric of space and time. These developments don't just affect scientific models. They strike at the heart of philosophical questions about reality and our place within it. If these discoveries are confirmed, they could completely transform what we think we know about existence itself. As debates about the universe's true age rage on, it's becoming clearer that we're entering a new chapter in cosmic exploration. The decades ahead may bring clarity to questions that have puzzled thinkers for thousands of years. Whether it's finding stars older than the known universe or solving the riddles of dark matter and energy, the universe continues to hide truths just waiting to be revealed. The journey forward is all about questioning, testing, and refining our understanding of everything that lies beyond our tiny blue planet. Even though we don't yet have all the answers, the pursuit of knowledge is just getting started. So stay connected for more updates on these incredible revelations and emerging theories. Keep your curiosity burning because the future may uncover astonishing breakthroughs we can't yet imagine. If you're passionate about space science and want to stay informed, make sure to subscribe to our channel, hit that like button, and switch on the notification bell so you never miss an important update. As we journey further into the depths of the universe, we stand on the brink of game-changing discoveries. The James Webb Space Telescope has already delivered mesmerizing images and data about remote galaxies, distant planets, and other celestial marvels, but this is only the beginning. As it continues its mission, Webb may reveal information that completely redefines our grasp of how the cosmos works. Among the most thrilling aspects of this exploration is the ongoing search for alien worlds that could harbor life. With a growing number of exoplanets discovered in the so-called habitable zone, the idea of life beyond Earth is becoming more plausible than ever. Even the detection of simple microbes on another planet would revolutionize biology, rewrite our theories of evolution, and change how we perceive our role in the universe. On top of that, the investigation into the mysterious forces of dark energy and dark matter will challenge and expand the boundaries of physics as we know it. These unseen forces make up most of the universe's mass-energy content, yet we still know incredibly little about how they function. Solving these puzzles could unlock entirely new layers of reality. At the same time, astronomers are continuing to study how galaxies behave. For instance, the unexpected discovery that stars in the Milky Way's outskirts are moving slower than expected has already forced a re-evaluation of existing models of galactic dynamics. This could mean that the Milky Way and possibly other galaxies contain less dark matter than assumed. If true, it could reshape how we understand gravity and the universe's structure. This is a perfect case of how fresh evidence can force dramatic changes in long-standing scientific beliefs. Likewise, the growing idea that galaxies evolve in ways we haven't yet fully grasped underlines a need for a more sophisticated approach to studying the universe. Could the cosmos be far older than our current model suggests? Are there parts of its story we've barely begun to uncover? These are the big questions astronomers will keep chasing as more data pours in from present and future missions. With every breakthrough, it's clearer than ever our current understanding is just the beginning. There's still so much left to explore, and the more we discover, the more we realize how much remains unknown. This endless drive to uncover truths and ask deeper questions is what powers the human spirit of scientific discovery.